to deal with quadratics in modeling functions. So here, an example of this is a kid kicks the ball up in the air and eventually touches the ground. Now the question here is, how long was the ball airborne? So as you can see, this is the given equation. So we need to find the exact time, or approximately the time the ball flew until it reaches the ground. So we can see the path here. So as it goes up, and because of gravity, it eventually went down. So as you can see, it looks like a parabola, and a parabola is also a quadratic. So here we have a quadratic equation. So P represents the position of the ball, as you can see here. So if we substitute T, or a time, it will eventually give an answer to P. So for example, if time is 0, which is an initial time, so probably it will be here. If we substitute 0, then 18t squared and 44t will have to be 0, so the final answer will be 2 feet, which is reasonable since before kicking the ball, he might be holding the ball like 2 feet off the ground. So as we substitute numbers, it will give numbers to P. So the question is, when will the ball end? So after kicking, as it goes up and down, the distance of the ball from the ground will obviously be 0, and that's when the journey of the ball ends. So this will be the question now. So we will have to make this equation to 0. So we do this: 18t squared plus 44t plus 2 is equal to 0. Now since this is a big number and it will have to get messy, we can actually factor this out by 2. So we will have negative 9t squared plus 22t plus 1 equals 0. Now we all know this cannot be factored. This cannot be factored, so we will have to use the quadratic equation, the old quadratic equation. So we will have time is equals to b squared negative b plus minus square root of b squared minus 4ac all over 2a. So we'll have to write here. The equation is negative b plus minus square root of b squared minus 4ac all over 2a. Now we all know that negative 9 will be our a, 22 will be our b, and 1 will be our c. So here we now substitute these values a, b, c to the formula. So now negative b, so we will have negative 22 plus minus the square root of b squared, which will be 22 squared minus 4ac. So that will be 4 times negative 9 times 1. So we all know negative 9 times 1 is equals to 9. Now since it's negative, this minus sign will have to be positives, because negative times negative is equals to positive. So plus 4 times 9 square root all over 2a. So 2 times negative 9 will be equal to negative 18. Now we have that. Now we can simplify it even more. T equals negative 22 plus minus square root of, now we will solve the inside of the square root. Now 22 squared plus 4 times 9, we can use the calculator here. So 22 squared plus 4 times 9 is equals to 520. So this will be square root of 520 all over negative 18. So we will have to solve the square root of 520. So square root of 520 is equals to 22.80. So negative 22 plus minus 22.80 all over negative 18. Move up. Now here we will have to choose whether we will use the minus sign or the plus sign in solving this. So we will have to think about it. If we use the plus sign, since this is 22.80, which is bigger than negative 22, the numerator will have a positive numerator, positive value. But since we will divide it with a negative denominator, the answer will be negative something, which will be impossible since there are no negative time. So therefore, we will not use the plus sign. Instead, we will use the minus sign. So the solution will be negative 22 minus 22.80 all over negative 18. So we will solve that. So negative 22 minus 22.80 all over negative 18. Now we will have 2.49 seconds, approximately the time when the time of the ball's journey until it hits the ground, until it stops its journey, will now be 2.49 seconds. Now to make things sure, let's substitute this 2.49 into the original equation, which will be this one, since our goal is to make this one 0. So negative 18 times 2.49 squared plus 44 times 2.49 plus 2. Now it will be 0.0418. So it is still close to 0, since this is just an approximation. So this is your final answer. I'll see you in the next one.
So the given problem is a box with an open top is to be constructed from a square piece of cardboard that is 4 feet wide by cutting out a square from each side of the 4 corners and bending up the sides. Find the maximum volume of the box. First, we get the volume by multiplying the length by width and multiplying it with the height. Now, to get these values, we get it from here. The cardboard has 4 feet, and we represent this measurement as x. Now to get this value, we subtract 4 feet from 2x's, so we get 4 minus 2x. Same with the length. Now we substitute it in this formula. We get 4 minus 2x squared because length times width is same as 4 minus 2x times 4 minus 2x, or 4 minus 2x squared, times the height, which is the height of the box, like, because we fold it up and we get this height and we represent it with x. Now we derive the formula 4 minus 2x squared times x. In deriving this, we use product rule. The product rule is first times the second derivative plus second times the first derivative, which we will be using chain rule. This is the answer, and we get the GCF 4 minus 2x times, we get the 4 minus 2x, that will be only 4 minus 2x, minus, if we get this will be gone, and negative 2 times x is negative 4x. So combine like terms, the result will be 4 minus 6x times 4 minus 2x, and it is equals to 0. Now we have two values for x. To get the two values, we simply do this. 4 minus 2x equals to 0, transpose 2x. It will become positive 2x divided by 2, and x equals to 2. The other value for x is 4 minus 6x equals to 0, transpose the 6x, and divide both sides by 6, and we will get the answer x equals to 2/3. Now to get the maximum volume of the box, we simply substitute from the original equation of the x, value of x, which is 0 and 2/3. Now 2 and 2/3, excuse me, sorry. Now if we use the value x is equals to 2, the result will become 0. Now that's not the maximum volume of the box. If we use the 2/3, the result will be 128 over 27, or 4.74 feet cube. And that's our final answer.
So hello everyone, we have this problem. We have a rectangle that have unknown length, but the perimeter of the rectangle is 50 feet. So for the question A, what is the width of the rectangle as a function of L? And for the question B, what is the area of the rectangle in terms of its length when L is 5? So as we can see here, I have drawn a rectangle. So a rectangle has its length, which is represented by this L, and width, which is represented by W. So we all know that rectangle has two length, which is this one and this one, and also width, this one and this one. So let's go to the question number A. So the given is the 50 feet, which is the perimeter of the rectangle. So what we can do here is we put the equation of the perimeter, which is the total area of, or the total area of this rectangle. So as what I have said, rectangle has a 2 width, that's why I put 2W plus 2L, and it is equal to the given perimeter, which is 50. So to get the width of the rectangle as a function of L, what we do is we simply transpose 2L to the other side here. So it would look like this. 2W is equal to 50 And so since we transfer 2L, the positive sign will be changed to negative. So there you go. So since both sides are divisible by 2, we both multiply them also by 2, which is I did here. So 2 will be cancelled out here, and we will left with W, or the width. Then 50 divided by 2, so there you go, it's 25, and 2L divided by 2 rather is L. So there you go. So that is how you get the width of the rectangle as a function of L. So for my question letter B, we have the given, which is the L is equal to 5 feet. So we all know that to find the area, we need to multiply the length to the width. So what did I do next is L times, I substitute rather the equation from what did I get from my equation in letter A problem, which is 25 minus L, to my solution in letter B, which is 25 also minus L. So there you go. So what did I do next is I substitute 5 feet to the L. So we have this 5 times 25 minus 5. So remember, the important thing in this equation is that always remember to add a parenthesis so that this one will not be affected when these two will be solved. So here I subtract 25 to 5, and that gives us 20, and 5 times 20 gives us 100 feet squared. So that is the area of the rectangle in terms of its length.
So good morning everyone. Our topic for today is modeling with linear equation. So here is the problem. A gym is offering a deal with the new members. Customers can sign up by paying a registration fee of $200 and a monthly fee of $39. So here is the question: how much will the membership cost a member by the end of the year? So write the given here. $200 is the registration fee, then $39 is the payment per month. Then the fee is the amount that we will pay in total for a membership. So here is the equation: P equals 39 times M plus 200. Then the formula for this is Y equals mx plus b. So y is the dependent variable, while the x here is the independent variable. Here is the dependent and x is the dependent variable. So here we have to plot this. P equals 39 m plus 200. So P is stand for y, the dependent variable. Then here is the independent variable. So P is the dependent variable, M is the dependent variable. Then here for this 200 is y intercept. Is y intercept. Then 39 is the slope. So we have to graph this. So here is the p-axis, then here is the months, number of months. So $200 is the registration fee here. Then if the payments in 1 month is 239 here, second month is 278, then third month costs 317. But we going back to the question is, how much will the membership cost a member by the end of the year? So 1 year equals to 12 months, rather 12 months. So 12 months, so P equals 200 plus 39 times 12, because end of the year. So 39 times 12 equals, here is 8, 7, here is 9, 3, so 468 equals 200 plus 468. So P equals 668. That this is the amount that we pay for the end of the year. At the end of the year, so guys, here is our final answer. Then I'm gonna show you the graph of this here. First is the registration, 200. Then for the first month was 239, second month for 278, third month is 317, and the 12 months that we were looking for is $668. Here is the number of months, here is the number of payments. So that's all. Thank you for watching.
So the next problem will be all about optimization problem. So here is an example. Find dimension of a rectangle with an area of 2000 square meter whose perimeter is as small as possible. So we will find the smallest possible dimension of a rectangle which have an area of 2000 square meter. So here is the representation graph of the rectangle. So as you can see, the x variable represents the length and y variable represents the width. So here is the equation P equals 2x plus 2y. So first step, we must find the constraint. So we get this 2000 equals x times y, because 2000 is the area and the variable we use is x multiplied by y. So we transpose x so that we have the value of y. So the only variable we want to find next is the value of x. So we substitute then the y, because we all know that y is equals to 2000 over x. So our perimeter is now p equals 2x plus 2 multiplied by 2000 over x. So we multiply 2000 over x rather by 2, and we get this. And we get the first derivative of it, so it will be 2 minus 4000x to the power of negative 2. So we multiply x squared by 2, so we get 2x squared minus 4000 over x squared. So next is we evaluate 2x squared over 4000, equate it to 0, so we could find x. So first we use the denominator, which is 2x squared minus 4000 over 0. So we divide both sides by 2, so we get x squared equals 2000, and we transpose 2000 to the other side, so it will get positive 2000. So we extract x squared by the square root, so our x would be x is equals to square root of 2000. So next is the denominator, so x squared equals 0. So we don't have a value of 0 because there's no dimension which is equals to 0, so x must not equals to 0. So therefore the value of our x is square root of 2000. So we have now the value of x and y, so we must substitute it to the first equation that we have, which is p equals 2x plus 2y, and we will have like this: the constraint 2000 equals the square root of 2000, which is the x, multiplied by y, which is 2000 over square root of 2000. So square root of 2000 multiplied by 2000 over square root of 2000 is equals to 2000. So the value of x and y are correct because it is equals to 1000. So therefore the dimensions are square root of 2000 by square root of 2000 meters, and the rectangle is a cube. So this is the final answer. So thank you for watching. God bless.